Welcome to the very first set of notes for the Renfrew High School Maths Department Higher course. This is the straight line, obviously, as it says there, and we're going to calculate the distance formula, or rather the distance between 2 points, and we'll calculate the midpoint. The purpose behind these video lessons is for a couple of reasons. Either if you've been off, absent, and you have to get caught up with the higher class, then you can do that. All of the classes in the department are using the exact same notes. The way that I do things, this is me, Mr. Geddes, it might be a wee bit different from some of the other teachers, but the end result should be the same. So you can either use this two ways. You can watch this before class and go in knowing what's going to come up, or watch it after and fill in notes then, or as I said, when you're absent, you can use these videos to get caught up. So we're going to dive straight in. First of all, I'll talk about a couple of things about the higher course that you should know. It always starts with a straight line, and to begin with, we covered the distance formula and the midpoint, as I said. But to highlight a few things that are going to come up this year, we've got these bullet points here now. There are a couple of things missing, but these are the big points. Recurrent relations and vectors have now been added back into the higher course. They should be on that list there. I'm sure we can add them in later, but just take a look down that. You'll recognise some of them. In fact, some of the topics that you've seen before, as it says here in the notes, some of the National 5 topics will come back up here in Higher Maths and will be expanded on, and you can do more work with them. And for some reason, algebra is spelt strangely. You can sort that in your notes. But we're going to be covering some of these topics from National 5 now. Fractions, surds, indices, factorising, and also in there I suppose there should be your favourite type, the difference of two squares. That's going to come up as well. Trigonometry is coming back, cast diagrams, equations, SOHCAHTOA, good old-fashioned SOHCAHTOA, right-angled triangle trigonometry. And then Pythagoras is coming back as well. The thing to remember though sometimes is that in higher maths you don't get the same number of marks as you once did, whereas a Pythagoras in the past might have been worth 3 or 4 marks. It's now only worth maybe 1 when it comes to some of the trig equation questions, some of the compound angle formulas that come in Unit 3. But this just gives you a wee idea of some of the things that are coming back up, some of the things that you'll have to use. And one of the big ones I would say is indices there plays a big part in higher maths, big part. So if you aren't great with indices, now's the time to go back and sort it out, do a wee bit of extra practice so that you get back up to speed. Okay, so let's get started. What I'll do is I'll say to you when you should pause the video if there's some questions that you have to attempt. I'll pause for a couple of seconds, you can pause it, and then when you're ready just compare the answers as I read them off, okay? So we'll start with this. This is the distance between 2 points, better known to me and to the rest of the maths world as the distance formula, finding the distance between 2 coordinate points. The distance formula is based around the work that you guys have seen already. In fact, it's based around something I just mentioned a second ago. It's based around Pythagoras' theorem. And you can see at the very bottom of the screen here just now is the distance formula down here. Very complicated looking, but actually very simple to begin with. You can also see, if you look at the diagram here, we've got our classic x1, y1, x2, y2 set up from when we're calculating the gradient of a line. However, what we're really interested in for the distance formula is the distance or the difference between these two coordinates. That's what we're looking for. The difference in the vertical and the difference in the horizontal. If we do that and we square them, as you can see down here in the formula, so find the difference in the vertical, find the difference in the horizontal, square them, and then find the square root. And you can see that at work down here. The distance is the square root of x2 minus x1 all squared plus y2 minus y1 all squared. Now, as I say, it looks complicated, but it's actually really straightforward when you try it. Over here it says the note as well. y2 minus y1, x2 minus x1. It comes from the method above, from Pythagoras, and also from finding the gradient. But there's a lot of squares and square roots going on here. So let's see what we can do. We'll be given a wee example here, and we can do this together. You guys can fill in your notes as we go. We can start with labelling the points. We can do that just now. In the future, you might not want to bother with that. There's x1, y1, and x2 and y2, just like we did back when we were doing straight line in National 5. This time though, all we're interested in is the distance between these 2 points, and it says calculate the length of the line AB. So we're going to go and put down, we've labelled them, we're going to put down the word distance. So that is the distance equals large square root sign y2 minus y1 is 4 squared plus x2 is 3 minus, I'll look for the double negative there, x1 is negative 2. Underneath, we'll maybe tidy this up a wee bit. We'll keep the square root for just now. 1 minus 4 negative 3 squared plus there, I missed a bracket, make sure you get the right number of brackets. 3 plus 2 is 5, 5 squared. Negative 3 squared is 9 plus 5 squared is 34. 9 plus 25 is 34. And normally when we're doing the distance formula, we can leave the answer as a square root. If it's a surd, you'll need to watch out for simplifying surds. So keep your eye out for that. So you can accept root 34, or at this stage, whatever the square root of 34 is would be acceptable as well. But for the most part, we'll leave it as a root. So square root of 34, that's 9 plus 25. Notice how we skipped the line there. That's quite common in higher maths. Okay, shifting down to the second question, you can see just what I was talking about earlier on. In higher maths, fractions are really going to come back with a vengeance here. We've got a half, and we've got negative 15 over 4. This is the norm for higher. You can get fractions coming up in virtually at any point. And again, look, our job is to calculate the distance between the points a half and negative 15 over 4 and negative 1, negative 1. So again, let's start by labelling for just now. We won't need to do this in the future. x1 and y1, x2 and y2. We'll pop our distance formula down. Distance equals square root, and we'll be very careful this time. We're going to do negative 1. Take away, that's y2 minus y1, so that's going to be negative 15 over 4 squared plus x2 negative 1 squared, nope, sorry, that's just a negative 1. And we're going to take away a half, and we'll square the result. So I think I missed the bracket there at the front. So zoom in a wee bit just so we can get this done properly. Okay, so the key to this is to remember what 1 can be changed to be. If we want a common denominator here to make our lives a wee bit easier, we can go for negative 4 over 4. So we're changing negative 1 to negative 4 over 4. And this in here, we can change it from a double negative to plus 15 over 4. And of course, we remember that we're still to square that. The back part, you could change 1 to be negative 2 over 2. And we have to take away another half. And that's to be squared. The front here, let's just take this a wee bit at a time. We've got negative 4 over 4 plus 15 over 4. It's going to give us a grand total of 11 over 4. That's squared. Plus the back part there, negative 2, take away 1. We're going to get negative 3 over 2. And that's squared again. Meaning that we get square root of 11 squared is 121 over 16 plus negative 3 over 2 is going to become 9 over 4 we're going to take these and we're going to make sure that in order to do this, we could go with common denominators again. We'll times the back by 4 to get 16 as the common denominator. So that's going to give us 36 over 16. That means we're going to get a square root of 157 over 16. And I'm going to leave it like that. That's not a typical answer, but one of the answers that we could get in higher maths could be something as crazy as that top heavy fraction there, 157 over 16, or the square root of 157 over 16. So long as I'm not missing anything there with the square roots, that could be our answer. So shift you on to for a few for you to try. Remember, use the distance formula, x1, y1, x2, y2, and calculate the distance between these points. And I'll give you a second to pause just now. Okay, here are the answers. For the first one, the answer should be the square root of 2. For number 2, I'm looking for the square root of 85, or I'd accept 9.22, but you're quite welcome to leave them as square roots just now. For number 3, I'm looking at 104. For 4, the square root of 26. For 5, the square root of 13. For 6, the square root again of 104. Those are your answers for the distance between those points. A lot of people forget that the distance formula exists as we get further on. It comes back in the circle topic, which is much later on in higher maths, but it is a very important formula to remember. Okay, so do your best to remember the distance formula. Quick reminder before we jump on. There it's there, x2 minus x1 all squared plus y2 minus y1 all squared. Now it doesn't matter whether you do the x2s first or the y2s because of this plus in the middle. Because you're adding it this time, it doesn't matter if you've got the y2s at the front or the x2s, etc, etc, okay? So the midpoint is the second thing that we've got to cover here just now. The midpoint is by far easier than the distance formula. This is put as a midpoint formula, but really all you have to do is to find the halfway point between 2 points. You're going to, as it says here, take the x's, add them together and half it. Take the y's, add them together and half it. Now there is no extra mark for writing the formula down on this. To find the midpoint, add the x's and half it, add the y's and half it, and you're done. There's no fuss or muss here. We're just going to find the midpoints between 2 points by adding the x's and halving it, add the y's and half it. The only thing to do is to remember that we're dealing with negatives here, so mistakes can be made. So I'll use capital M for the midpoint. The midpoint between these 2 points, 1 and 7, and negative 4 and 8. Let's, for the sake of it for this one, let's add the x's and half it using the wee formula set up. That'll be 1 plus 7 divided by 2, negative 4 plus 8 divided by 2. And we can find the midpoint by adding 1 and 7 to get 8 and half, and it was 2. Add negative 4 plus 8 to get 4 and half that to get 2. So we get 4, 2. That was 8 over 2 becomes 4, and 4 over 2 becomes 2. And the midpoint is 4, 2. You can think of it as the average between 2 points, but add them and half it, add them and half it is the way to go. And because it's as simple as that, because you've dealt with negatives before, we can have a go at these midpoints here. There's 3 of them. You can feel free to pause the video and then start it up in a second. Okay, here are the answers for the midpoints of these coordinates. The first one for A, the midpoint, let's zoom in for a second. The midpoint, add the x's and half it, negative 4 plus 16 is 12, divided by 2 is 6. Add 10 and negative 8 to get 2 and half that to get 1. That midpoint is 6, 1. Over here, the midpoint, capital M, Set up the brackets. Let's add the x's. That's going to give us negative 32 divided by 2 will give us negative 16. Add negative 1 and 9 to get 8 and half that to get 4. Add and half, add and half. Over here for C, midpoint again. Some people like to maybe go a wee bit further than just M. There's nothing wrong with using the word midpoint for just now. So 28, take away 10, I'm adding on negative 10, is 18. Half of that is 9. Negative 7, add on negative 17 will get me down to negative 24. Half of negative 24 is negative 12. And it's that straightforward for the midpoint. Add the x's in half, add the y's in half, and you can find the midpoint very quickly. 1 mark for that is all it's going to be giving you. Again, another important one though for what's to come. This is just the beginning for these straight line. So 2 skills, find the distance, find the midpoint. Now just to expand a wee bit on that, we've got one last question here for this set of notes, and that is in the diagram here below. A 9, negative 2 lies in the circumference of the circle with centre 17, 12, and the line AB is the diameter of the circle. Find the coordinates of B. So there are 2 ways that we can go about this, or rather, there are 2 ways that teachers teach this, or 2 names I should say. What we are going to do here is, as I would call it the count on method. Other teachers will call it stepping out. Sounds like that dance movie, Stepping Up to the Street. But stepping out is the other one as well. They're the exact same thing. You're going to step on, or count on from one point to the next. And since we're in a circle, the distance, or the difference between the points on the x-axis and the y-axis will allow you to go and find the next coordinate point. I'll explain what I mean. So if we label the points, which is a good idea, is at 9, negative 2, and the point C is at 17, 12. There we go. Think about how far that is from A along to C. Well, that's a chunky pen. Let's bring that down a wee second. How far is it from A to C along the way, and how far up? So from 19 to 17, that's a distance of 8 units. From negative 2, let me sort that too, can't have that. From negative 2 up to 12, that's a distance of, it's not 10, remember, it's negative 2 to 0, and then 0 to 12, that's a distance of 14. And then the stepping out to the streets method is going to tell us that we're going to count on and up so that we can get to B. So if C is at 17, 12, we again need to go along 8 and up 14 from that point to get our point B. So point B will be 8 along from 17. That means it's at 25. 17 plus 8, 25. And then 12, we're going to go up how many? 14. That's going to land us on 26. So using the count on method, you go along and up, but the exact same number each time. So it's related to the 2 formulas that we just talked about. And again, another important couple of things to remember for the future. We've got the count on method. Stepping out is also another name for it. And they're both related to the topics that we talked about here today, which was the distance formula up here, and also the midpoint formula, which is there. Okay, any questions, don't hesitate to get in contact through the Teams page or talk to your teacher in class. Good luck.